Hello friends, first of all thanks to Professor Sachin Hatkar sir to give me this opportunity. My name is Abhishek Rajaram Chatse, studies in B.SC third year in Others Education Society Hingoli under the University SRT MUN Nanded. So we will prove the theorem. In the theorem part A is if a set is linearly independent then any subset of it also linearly independent. And the part B is if a set is linearly dependent, then any superset of it also linearly dependent. So the statement of the theorem is in a vector space V, suppose in curly bracket V1, V2 dash 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 Vn is an ordered set of vectors with V1 does not equal to 0. The set is linearly dependent if and only if one of the vectors v2 v3 dash dash vn from say vk belongs to v1 v2 dash dash vk minus 1, that is vk belongs to v1 v2 dash dash vk minus 1 for k is equal to 2 3 dash dash n. So the proof is suppose vk belongs to v1 v2 dash dash vk minus 1, then vk is a linear combination of v1 v2 dash dash vk minus 1. Thus the set in curly bracket v1 v2 dash dash vk is linearly dependent, and hence the set v1 v2 vn is linearly dependent. Conversely, suppose that the set v1 v2 vn is linearly dependent. Consider the set s1 is equal to v1, s2 is equal to v1 v2, s3 is equal to v1 v2 v3 dash dash dash, sn is equal to v1 v2 dash dash vn. In the next part, then s1 is linearly independent, and by assumption sn is linearly dependent, we go down the list. Choose the first linearly dependent set. Let sk be that set, then sk is linearly dependent and sk minus 1 is linearly independent, as we have alpha 1 v1 plus alpha 2 v2 plus dash dash plus alpha k minus 1 vk minus 1 plus alpha k vk equal to 0. Then if alpha k equal to 0 comma alpha 1 v1 plus alpha 2 v2 plus alpha k minus 1 vk minus 1 equal to 0, but alpha 1 equal to 0, alpha 2 equal to 0, alpha k minus 1 equal to 0. This gives that v1 v2 dash dash alpha k is linearly independent, which is not possible, and hence alpha k does not equal to 0. But then alpha k vk equal to minus alpha 1 in bracket v1 plus minus alpha 2 in bracket v2 plus in bracket minus alpha k minus 1 vk minus 1. Then vk is equal to minus alpha 1 divided by alpha k v1 plus minus alpha 2 divided by alpha k v2 plus alpha k minus 1 divided by alpha k in bracket vk minus 1. Vk belongs to v1 v2 dash 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 vk minus 1. Hence the theorem is proved. Thank you.